About how to multiply decimals by decimals. Mr. Joe plans to host a dinner party for his friends and family. His guest list includes 9 and 5/10 people. The 0 and 5/10 are half of a person, Eric, his nephew, because he does not eat that much food. If each person plans to eat 8 and 2/10 ounces of, let's say, pork steak, how many ounces of pork steak will he need to buy at HEB? So I have 9.5 people who are coming to this party. You could draw 9 stick figures. 1, 2, 3, 4, 5, 6, 7, 8, 9.5. My little nephew Eric. Each person eats 8.2 ounces, 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 and this person, half a person will eat half of the 8.2 ounce. Isn't this just repeated addition, which is really multiplication? It is. So, I can extend the screen. So, why don't I just multiply 9.5 people by 8 and 2/10 ounces of pork steak. So let's multiply this. So when you do this, you just multiply as normally. Some teachers teach it as this way. You multiply it without the decimal point, and then you go back and put in the decimal point in the answer. Many ways to do it. So 5 times 2 is 10, carry the 1. 2 times 9 is 18, plus 1 is 19. Don't forget your placeholder. 8 times 5 is 40, carry the 4. 8 times 9 is 72, plus 4 is 76. So I bought 7,790 ounces of steak. No. I forgot the decimal point. I do need a decimal point. So how many places are behind the decimal point? There's one place there. What about this one? There's one place there. So this is in the tenths place. This is in the tenths place. What is tenths place times tenths place? 10 times 10 is a hundredths place. So I need to put the decimal point to get a hundredths place here. Let's see, where should I put it so it'll be a hundredths place? I could put it right here. Nope, that's the tenths place behind it. What do I put it right here? Do I see a hundredths place behind it? It is. So I will buy 77 and 90 hundredths ounces of pork steak. Another way you can do it is this way. How many places are behind the decimal point? 1. How many places are behind the decimal point? 2. So there are 2 places behind the decimal point. In your answer, you will need 2 places behind the decimal point. Are there 2 places behind this decimal point? There are. Many ways. Another way to do it is this way. Let's estimate. 9 times 8 is 72. So if I just multiply the whole numbers only, it's 72. So where should I put the decimal point so the answer is near 72? Between the 7 and 9, so it's 77 and 90 hundredths, which is close to 72. So it depends on how you want to complete it. So let's go skip. Let's do a very quick thing about how do you do it with whole numbers and decimal. This is a review from 5th grade. Multiply 3 by 6/10. You have 3 groups of 6/10. So let's shade it in. 1, 2, 4. 1, 2. This is a tenth. This is 2/10, 3/10, 4/10, 5/10, 6/10. That is the first group of 6/10. This is the second group of 6/10. And this is the third group of 6/10. So what do you have as your final answer? 1 and 8/10. But how do you get it without modeling? Can you answer this question without modeling? Let's see. You have 3 groups of 6/10. So it's 3 times 6/10. You could also write it like this way. 3 times 6/10. And then so you're going to say, aren't we supposed to line this up? No, you only line up the decimal point in adding and subtracting. But when it involves multiplying, you do not have to line up. the way I teach it, the way I do it is I just multiply as imagine it's just whole numbers. What is 3 times 6? 3 times 6 is 18. What place value is the 6 in? It's in the tenths place. So I need to put the decimal point so I see a tenth in my answer. 1 and 8 tenths. Another way you can do it is this one. How many places are behind a decimal point? 1 place. In your answer, you need to have 1 place behind a decimal point. And there it is. Many ways to do it. Many ways to do it. All right, so let's just quickly do this one. Let's do this one. What is 4 groups of 5 tenths, or 4 times 5 tenths? So let's shade it. This is 5 tenths. 1, 2, 3, 4, 5. 5 tenths. That's the first group. Here's the second group of 5 tenths. This is the third group of 5 tenths. And this is the fifth group of 5 tenths. Hold up. Is that the whole thing? Is that 2 whole? No, it couldn't be that easy. The answer is 2 whole. But how can you do it without modeling? So you can multiply it like this way. You can multiply it like this way. Again, the way I multiply is I'm just pretending there is no decimal point. I'm just going to imagine this is kicked back gone. What is 4 times 5? 20. What place value is this 5 in? It's in the tenths place. So in your answer, it needs to be in the tenths place. So 2 and 0 tenths. Now the way you can do it is this way. How many places are behind this decimal point? 1 place. In your answer, do you have 1 place behind your decimal point? I do. So let's try one now without modeling. 6 times 6 tenths. So another way to write this is 6 times 6 tenths. Imagine there's no decimal point. What's 6 times 6? Multiply it just as the whole number. That's 36. What place value is a 6 in? In the tenths place. So I know the answer will be 3 and 6 tenths. How many, or you can do it this way. How many numbers are behind a decimal point? 1 number, 1 digit. In your answer, well, do you have a 1 digit behind a decimal point? I do. What about this one? 2 groups of 82 hundredths. So you can multiply. Ooh. Should I multiply it like this way? No, that's kind of confusing. I'm going to multiply with the more digits on top. So I'm going to multiply it as this way. Because remember, you try to remember to multiply this. Pretend there is no decimal point. It's just whole numbers right here. So it's really 82 times 2. So that's 4. 2 times 8 is 60. So it's 164. Now you go back and figure out where the decimal point go. What place value is 82 in? In the hundredths place. So your answer needs to be in the hundredths place. 1 and 64 hundredths. Or another way to do it is, how many digits behind a decimal point? 2 digits. In your answer, do you have 2 digits behind a decimal point? I do. I do. So let's keep on going. Now, what if you have 2 decimals you need to multiply by? So let's say, what is 8 tenths times 2 tenths? Or what's 8 tenths of 2 tenths? So let's see. This is a model of 8 tenths. This is a model of 2 tenths. They merged them together because it's saying, in this 2 tenths right here, in this 2 tenths, what's 8 tenths part of it right here? What is 8 tenths part of it? Let's count. 2, 4, 6, 8, 10, 12, 14, 16. But what place value is it? Let's see. This is in the tenths place. This is in the tenths place. What is tenths times tenths? 10 times 10 is hundredths place. This whole number needs to be in a hundredths place. So the answer is 0 and 16 hundredths. Another way you can do it is this. How many digits are behind this decimal point? 1 digit. How many digits are behind this decimal point? Another digit. That's 2 digits behind these decimal point. Do you have 2 digits behind your decimal point? I do. Check. Oh, I did it correct. So, for example, let's slide this. What if the question is, what is 4 tenths of 7 tenths? Let me draw 7 tenths first. 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths. What is 4 tenths of this? 1 tenth of it, 2 tenths of it, 3 tenths of it, 4 tenths of it. So it's saying this part right here. What portion, what decimal is that? Let's see, 4 times 7 is 28. And it's in the hundredths place. Why is it in the hundredths place? Tenths place times tenths place is hundredths place. Is this answer in the hundredths place? It is. Another way to do it, how many digits are behind this decimal point? 1 digit. What about this one? Another digit. That's 2 digits behind the decimal point. And your answer, do you have 2 digits behind the decimal point? I do. I wouldn't reset this if I knew how, but so I can, you know what? I don't need to reset. Let's try to do this without modeling, because you really have to know how to do this without modeling, guys. So we have 8 tenths times 3 tenths. Pretend that this is just multiplying whole numbers. So it's really 8 times 3. And what is 8 times 3? 24. But where does the decimal point go? Tenths place times tenths place is hundredths place. That's one reason. 0 and 24 hundredths. Or, how many digits behind this decimal point? 1 digit. Another digit. That's 2 digits behind a decimal point. Do you have 2 digits behind your decimal point? I do. So, next one. So let's get some harder stuff now. Oh, so in here, they already multiply these numbers. Can you put them in the decimal point in the correct place? So let's use what I've taught you. This answer is in the hundredths place. There is no decimal. Hundredths place times ones place is hundredths place. So where should I put this decimal point so it's in the hundredths place? I put it right there. 25 and 12 hundredths. And this one is in the tenths place. This one is in the tenths place. What's tenths place times tenth place make? Hundredths place. So I put it right here. Hundredths place. Another way to do it is this. How many digits are behind this decimal point? 1. How many digits are behind this decimal point? 2. Are there 2 digits behind this? There are. Let's try this one. This is in the hundredths place. This is in the tenths place. What's a hundredths times tenths? Thousands. Where should I put this so it's in the thousands place? Right here. Tens, 100,000. Let's see if it's correct. Let's try another way. How many digits are behind the decimal point? 2. How many digits behind this decimal point? Another one. 3. Are there 3 digits? There are. And our last example, tenths place times tenths place is hundredths place. 1 digit, 2 digits behind the decimal point, 2 digits. And And let's try one. So now let's try some real questions. The average lab rat weighs 425,000 kilograms. If there are 15 of them in the lab, how much do they weigh all together? So we need to multiply these. So just pretend it's multiplying just like regular whole numbers, like 425 times 15. Pretend this decimal point is not right here. If you want to, remove it if that confuses you. So can you just multiply 425 times 15? 5 times 5 is 25, carry the 2. 5 times 2 is 10 plus 2 is 12, carry the 1. 5 times 4 is 20 plus 1 is 21. I put a placeholder, smiley face. 1 times 5 is 5, 1 times 2 is 2, 1 times 4 is 4. And what does this add up? 5, 7, 3. So will all these rats weigh 6,375 kilograms? No, they'll be killer rats. We'll all be screaming for like, ah! So in here, let's return back that decimal point. What place value is the first? It's in the thousandths place. Times what place? Ones place. So our answer has to have a thousandths place. Right there. Or another way to do it is, how many digits are behind this decimal point? 3 digits. Does your answer have 3 digits behind it? It does. So it's 6 and 375 thousandths. So let's do some that are not on here. For example, What if you have to multiply 25 and 2/10 times 31 hundredths? Let's set it up. So 25 and 2/10 times 31 hundredths. Be 10. You're going to say, but don't I have to line them up, Mr. Joe? No, you don't have to line them up. Because when multiplying and dividing, you don't. Only adding and subtracting decimal. If you want to, if that's confusing, just erase these decimal point and pretend you're just multiplying normal, easy, whole numbers. So 1 times 2 is 2, 1 times 5 is 5, 1 times 2 is 2. Smiley face, our placeholder. 3 times 2 is 6, 3 times 5 is 15, carry to 1. 3 times 2 is 6 plus 1 is 7. 2, 11, carry to 1, that's 8. 7,812. That would have been the answer if these were both whole numbers. They are not. What place value is the 2 in? In the tenths place. What place value is the 31 in? In the hundredths place. Tenths times hundredths is thousands place. I put it between the 7 and 8. That's the thousands place. Or another way you can do it is this way. How many digits are behind the decimal point? 1 digit. How many digits are behind this one? 2 digits. So there are 3 digits behind the decimal point. Are there 3 digits? There are. I also teach it this way. In elementary school, you may have learned something called lattice multiplication. I'll be honest, this is what I prefer. This is what I grew up with. So I write down 25 and 2/10. On the side, I'll write 0 and 31 hundredths. So what you do is you separate each digit with, separate 0, 3, and 1 the digits, we're drawing a line, separate a 2 and 5 and a 5 and 2. Then you draw diagonal, 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 diagonal. This is something that all elementary teachers have taught, so this should not be like, what is he doing? You have seen this before. So, well, hopefully you've seen it before. So what you do is just multiply. What's 0 times 2? 0. What is 5 times 0? 0. What's 0 times 2? 0. What's 2 times 3? 6. But how do you write 6 here? The ones place is 6. The tens place is 0. Another way to write 6 is 0, 6. What's 3 times 5? 15. Tens, ones place. What's 3 times 2? 6. What's 2 times 1? 2. What's 1 times 5? 5. What's 1 times 2? 2. And then you add it up diagonally. This first one will be 2. If you add up all of these, 5 plus 6 is 11. Then you carry the 1 to the next column. What do you get when you add up all this? 2, 5, and 1 adds up to 8. What do you get when you add up all this? 6, 0, 6, 1, 0, 0 adds up to 7. And what do you, well, we don't really have to do this, but this is 0 and 0, so we're not going to write it down. And then, what place value is this? Hundredths place. What place value is this? Tenths place. Hundredths times tenth is thousandths place. Or, how many digits do you see behind a decimal point? 2, and another one is 3 digits behind a decimal point. So that's lattice. I personally don't care how you do this. If you like the traditional way, do the traditional way. But as long as you understand, you don't line them up. You only line them up for adding and subtracting. And multiplying, you just multiply as though it's just regular whole number, and then you count back. I like lattice because it doesn't matter if you line them up or not, you just answer it and you just find it. Let's practice another example. Let's try this one. 4 and 2/10 times 23 hundredths. So, if you're going to do it traditional way, you multiply 4 and 2/10 times 23 hundredths. You know what? Imagine that the decimal points are not here so you don't get confused. And let's just multiply normally. 3 times 2 is 6. 3 times 4 is 12. Placeholder. I draw a smiley face because I need friends. 2 times 2 is 4. 2 times 4 is 8. It adds up to 966. What place value is this 2 in? Tenths place. What place value is that? Hundredths place. Tenths times hundredths is thousands place. So it's 966 thousandths. Or, how many digits are behind here? 1 digit. How many digits are behind here? 2 digits. 3 digits behind. Let's do the lattice. If you prefer lattice, I honestly prefer lattice. This is what I grew up with. So we have 4 and 2 tenths times 23 hundredths. So you draw a square or rectangle. You separate the digits. Then you draw diagonals on each square. And then you just multiply it as a column and a row. 4 times 2 is 8. 2 times 2 is 4. 4 times 3 is 12. 3 times 2 is 6. Then you add up each column diagonally. This is 6. What's 4, 0 plus 2? 6. What's 0, 8, and 1 add up to? 9. 966. Hey, same answer. But let's count the decimal point value. Hundredths place times tenths place is thousandths place. 966,000. Or, how many digits? 2 digit with another digit is 3 digits behind the decimal point. So the main thing what we're talking about here is how to multiply decimals. If you like the traditional way, all you do is just multiply as normal, easy whole numbers. Then you get an answer, a whole number answer. Then you go back and decide what decimal point, where will the decimal point go? So, for example, if it's tenths place times hundredths place, it'll be thousands place. If the question was, what happened if it was this one? Tenths times tenths. Then your answer will be in the hundredths place. And for this question, if it was, so 2 and 3 tenths and 4 and 2 tenths, they're both tenths times tenths, hundredths place. So just pick whichever one you prefer. So I like the lattice because you just multiply normally and you just count the decimal places. There's 2 digits behind the decimal point, 2 digits in my answer, or tenths times tenths is hundredths place. That is multiplying decimals.